Namaskar friends. We have already discussed the electron transport chain. Now from electron transport chain we will shift to the anaerobic respiration. That is the organisms, how the organisms utilize the glucose molecule without oxygen. That is anaerobic, that is no oxygen is required, and aerobic, that is no oxygen is required for breakdown of a glucose molecule. A glucose molecule, when breakdown, it occurs in 3 steps. We know the first step is glycolysis. It is glycolysis. Second step, it is a decarboxylation stage of, it is connecting stage of glycolysis and Krebs cycle, that is the decarboxylation stage. इसको बोलते हैं decarboxylation stage. That is पायरुविक एसिड से 2 कार्बन डाइऑक्साइड मॉलिक्यूल को निकाल फेंकते हैं. एक पायरुविक एसिड से 1 कार्बन डाइऑक्साइड मॉलिक्यूल को निकालना है. So it is a decarboxylation and production of acetyl coenzyme A. However, and from pyruvate to acetyl coenzyme A, and 3 step is 3 नंबर जो स्टेप होता है वो होता है क्या? क्रेब्स साइकिल. क्रेब्स साइकिल्स. सो इन 3 स्टेप्स में नॉर्मली द ग्लूकोज ब्रेक डाउन विद द हेल्प ऑफ ऑक्सीजन, दैट इज ए पार्ट ऑफ एरोबिक रेस्पिरेशन. एरोबिक रेस्पिरेशन, ये एरोबिक रेस्पिरेशन का पार्ट होता है. और एनाएरोबिक रेस्पिरेशन का पार्ट में ये दोनों, ये these are not required. ये दोनों पार्ट रिक्वायर्ड नहीं है. तो क्या जरूरी है? What is needed? Only the glycolysis. In anaerobic respiration, glycolysis is a common. That is, it is necessary. That is, glucose is converted from glucose to pyruvate. So glycolysis is very common in both case of aerobic and anaerobic respiration. So we'll discuss about the glycolysis. That is, from glucose to pyruvic acid formation is essentially needed. ग्लूकोज से pyruvic acid तक ये जर्नी बोथ एरोबिक एंड एनाएरोबिक रेस्पिरेशन में जरूरी है. और एक बात है क्या? एंड द नीडेड दैट anaerobic respiration is very common in both prokaryotes as well as in eukaryotes. It is a both, it is present in both prokaryotes as well as eukaryotes. It is both prokaryotes and eukaryotes. So this is very important. Now we will go through that. What will occur? What are the different aerobic respiration? What are the different anaerobic respiration? We have already aerobic respiration discussed, so we'll go through anaerobic respiration. That is anaerobic respiration. What are the different anaerobic respiration? In Ncert you will discuss that anaerobic respiration होता है क्या? एक तो होता है क्या? बोलो. Alcoholic fermentation. दोनों. और दूसरा है लैक्टिक एसिड फर्मेंटेशन. ये फर्मेंटेशन क्या होता है और क्या होता है? NCERT, इफ विल गो थ्रू NCERT, देन देयर इज रिटन दैट एक क्या एरोबिक और एनाएरोबिक रेस्पिरेशन में डिफरेंस क्या होता है? एनर्जी प्रोडक्शन में, ड्यूरिंग द एनर्जी प्रोडक्शन एरोबिक रेस्पिरेशन प्रोड्यूस 36 or 38 molecules of ATP molecule, and in anaerobic respiration what is occurs? In anaerobic respiration only 2 molecules of ATP. So which is hazardous? Glucose you will take, produce less energy. Glucose you will take, produce huge energy. So aerobic respiration produce huge energy, 38, and anaerobic respiration it is only 2 molecules of ATP molecules is produced. So in case of anaerobic respiration only less than a 7% energy it is written in your Ncert book, that is if a glucose is completely oxidized in case of anaerobic respiration, then they will produce less than 70% of energy of a glucose molecule, whose less than 70% energy of a glucose molecule is produced by anaerobic respiration. And another important thing is given, that is not only this, the alcoholic fermentation is hazardous. Hazardous means it is hazardous for whose? It is hazardous for the organism who is developing it. That is, जो produce करते हैं उसके लिए खतरनाक है. That is yeast. बोलते हैं कि yeast molecule जो होता है yeast, yeast when produced only 13% of alcohol can be produced. 13% of alcohol can be produced by him. After the 13% of alcohol in a solution, that is if a yeast solution is given, then only 13% of alcohol will produced. That is after the 30%, when more than 13% alcohol if produced, then yeast will be degraded, yeast cell will be dead. Yeast cell will be dead. Yeast cell मर जाते हैं. Yeast cell. Yeast is that is a fungus. When they are responsible for production of alcohol. So after the 13% of alcohol, naturally produced it. Normally if we will give them environment, अगर yeast को दिया जाए एक environment जिसमें alcohol produce होता है, alcohol produce होगा, alcohol produce होने के बाद क्या होगा, 13% तक alcohol produce होता रहेगा. After 13%, what will happen? After 30%, they will be killed. That is they will not, they are the toxic. That is more than 13% alcohol is toxic for themselves. That is the yeast मर जाएंगे. So हमको वो 70% 80% जो अल्कोहल मिलता है वो कहाँ से मिलता है? नो, ये पहले तो 13% ही मिलता है. उसके बाद ये डिस्टिलेशन प्रोसेस क्या होता है? डिस्टिलेशन प्रोसेस is the process where the water molecules are removed from alcohol. That is a 13% alcohol that we are taken, that is mixed with more than 70-80%, more than 80% or 85-87% of water molecules are there. So when you remove the water molecules, then this will be converted into 13% to what? 70%, or as you require, even spirit can also be produced. So this is a procedure of so this is the anaerobic, some important topics of anaerobic respiration. So now we'll go to the what are the steps? Alcoholic fermentation. So first we will discuss about the alcoholic fermentation, that is the ethanolic product, how the ethanol is produced, that is the ethyl alcohol is produced from glucose. So this is the first stage, that is the alcohol dehydrogenase enzyme कैसे काम करते हैं. यहाँ पे पायरुवेट डिकार्बोक्सिलेज दो एंजाइम्स हैं. यहाँ पे दो एंजाइम्स हैं, या यू विल डिस्कस दैट. यहाँ पे दो एंजाइम्स है, पायरुवेट डिकार्बोक्सिलेज एंड अल्कोहल डिहाइड्रोजिनेज. पायरुवेट डिकार्बोक्सिलेज एंड अल्कोहल डिहाइड्रोजिनेज. नाउ ये जो this pen is not good, I will promise that I will change it in the next video. So this is not working properly and is getting a impression. When the percentage of alcohol is less, then this occurred. However, क्या होता है, मैंने जो डिस्कस किया पहले, फर्स्ट विल डिस्कस alcoholic fermentation. What is the alcoholic fermentation? Alcoholic fermentation में होता क्या है? Now, alcoholic fermentation from glucose, oh, it's not written. From glucose, it's a pyruvic acid production होता है पहले. Oh, another important thing I have not given here, that is during the anaerobic respiration, no cellular organelles are involved, only cellular cytoplasm is needed. That is that is in case of aerobic respiration, we know that is the mitochondria was the key factor. Mitochondria, that is a membrane bound cellular organelle. But in this case, fermentation, no cellular organelles. Any organelle is not only cytoplasm. That is, from alcoholic fermentation, what happens? From glucose to pyruvic acid. From glucose to pyruvic acid is, we know that from glucose to pyruvic acid, it's totally occurred in glycolysis process, and in this glycolysis process is occurred inside the cytoplasm. All the enzymes present in here, that is cytosolic enzymes. सारे enzymes ये ग्लूकोज से पायरुविक एसिड प्रोड्यूस करने तक यहीं पे है, साइटोसॉल में है. और पायरुविक एसिड, आफ्टर प्रोडक्शन पायरुविक एसिड क्या करता है? माइटोकॉन्ड्रिया में घुस जाता है. इफ इट विल एंटर इन माइटोकॉन्ड्रिया इफ ऑक्सीजन इज प्रेजेंट in an environment. If oxygen is not present, they will never enter inside the mitochondria. Mitochondria में घुसेगा ही नहीं, वो साइटोसॉल में रह जाएगा और क्या करेगा? इथानॉलिक फर्मेंटेशन करेगा. और इथानॉलिक फर्मेंटेशन दैट इज ए अल्कोहलिक फर्मेंटेशन. पायरुविक एसिड क्या करता है? पहले पायरुविक एसिड का स्ट्रक्चर देखना है पहले हमको. COOH, C11O, CH3. द पायरुविक एसिड से ये जो कार्बन डाइऑक्साइड है ना, C11O निकल जाता है. पायरुविक एसिड से एक कार्बन डाइऑक्साइड निकल गया, तो एक ग्लूकोज से फ्रॉम वन ग्लूकोज 2 molecules of pyruvic acid has produced. 2 molecules of pyruvic acids are produced. So from one glucose total 2 carbon dioxide will be released. 2 carbon dioxide released, and from pyruvic acid glucose this is enzyme is, इसका एंजाइम का नाम है पायरुवेट डिकार्बोक्सिलेज. सो पायरुवेट डिकार्बोक्सिलेज भी साइटोसॉल में होता है. पायरुवेट डिकार्बोक्सिलेज. So from pyruvate decarboxylase, pyruvic acid will be converted into what? Acetaldehyde. What acetaldehyde? CH3CHO. Acetaldehyde. Now, from acetaldehyde, what will happen? Ethanol will be produced. Ethanol. How the ethanol is produced? That is the ethanol, that is CH3, CH2OH, that is C2H5OH. Ethanol. How many molecules? From one glucose molecules, 2 ethanol will be produced. So 2 molecules of ethanol, that is one glucose, that is a 6 carbon. Here 2 carbon is given, 2 carbon is going, that is a 4 carbon is present. Here 2 molecules of, that is a 4 carbon. 1 molecule of ethanol contains 2 carbon. एक मॉलिक्यूल इथानॉल में क्या है? 2 कार्बन है. 2 मॉलिक्यूल इथानॉल में 4 कार्बन होंगे. सब मिल ये हो गया. और उसके बाद एसिटाल्डिहाइड जो इथानॉल प्रोड्यूस करते हैं, इसके लिए अल्कोहल डिहाइड्रेज एंजाइम. इसमें आप याद रखिएगा जिंक इम्पॉर्टेंट है. जिंक जैसे कोफैक्टर, ये बहुत ही इम्पॉर्टेंट फैक्टर है. सो फ्रॉम एसिटाल्डिहाइड टू इथानॉल. इसके बाद में ये एसिटाल्डिहाइड टू इथानॉल प्रोड्यूस करते हैं. कैसे? इसके पास 2 हाइड्रोजन, यहाँ हाइड्रोजन है 4 और यहाँ हाइड्रोजन है 4 हाइड्रोजन मॉलिक्यूल इज देयर. और हियर इट इज 3 2 5 1 6 हाइड्रोजन मॉलिक्यूल इज देयर. फ्रॉम वेयर दे कम गेट द हाइड्रोजन कहाँ से आया यहाँ पे? सो हाइड्रोजन डोनर इज प्रेजेंट as a NADH plus H plus. During the glycolysis, NADH plus H plus is produced during phosphate level phosphorylation, and this NADH plus H plus is reducing energy, that is during the formation of phosphoglyceraldehyde to PGA, phosphoglyceric acid. From aldehyde to acid, from aldehyde to acid, that is during the oxidation process. What happened? NADH are produced. This is a reducing energy, and these 2 hydrogen molecule will go from here to CH3, and they will also give the electron to acetaldehyde. So electrons will pass to the acetaldehyde, hydrogen will go to the acetaldehyde, they will be converted into ethanol. How many molecules? 2 molecules of ethanol are produced, and this is the oxidation, this is the reduction power, how the acetaldehyde will get the electron and proton. So this is the alcoholic fermentation, and we will go from alcoholic fermentation से हम लोग डिस्कस करने वाले हैं क्या ना? लैक्टिक एसिड फर्मेंटेशन। लैक्टिक एसिड फर्मेंटेशन में, लैक्टिक एसिड फर्मेंटेशन के लिए लैक्टेट डिहाइड्रोजिनेज इज नीडेड। लैक्टेट डिहाइड्रोजिनेज जरूरी होता है। लैक्टिक एसिड फर्मेंटेशन के लिए लैक्टेट डिहाइड्रोजिनेज जरूरी होता है। ये भी द कॉमन प्रोसेस। यहाँ पे भी एक जरूरी एक बात, वन इम्पॉर्टेंट थिंग इज दैट you should remember that whether it is the aerobic or anaerobic respiration, whether it is a alcoholic fermentation or lactic acid fermentation, one important thing is that from glucose pyruvic acid production is utmost needed. From glucose it is pyruvate. From pyruvate, in a alcoholic fermentation was two-step reaction, but it is a single-step reaction. That is from pyruvate, what happened? Directly lactic acid will be produced. Lactic acid will be produced. From pyruvate to lactic acid is produced. How? There is a from glucose 6 carbon compound, there is a 2,3 carbon compound, that is a, it is a 3 carbon compound, so 2 molecules will be produced pyruvate. From pyruvate to lactic acid, what will happen? From pyruvate to lactic acid, this is the enzyme name is lactate dehydrogenase. Lactate dehydrogenase. That is the lactic acid dehydrogenase enzyme. Now, in this case, very important thing is that no carbon dioxide is released. Very important difference from lactate dehydrogenase, from alcoholic fermentation to lactate fermentation. Carbon dioxide production नहीं होता है. No carbon dioxide released from pyruvic acid. From pyruvic acid, no carbon dioxide is released. So the molecular formula of this is C3H6O3. C3H6O3. Molecular formula is lactic acid C3H6O3. Very important thing is that lactate dehydrogenase enzyme not release carbon dioxide from the pyruvate. So pyruvate से carbon dioxide release नहीं करता है, तो pyruvate का जो formula है that is a C double bond pyruvic acid that is retained, वो रह जाता है. और उसके बाद क्या होता है, ये जो लैक्टेट डिहाइड्रोजिनेज पायरुविक एसिड को कहाँ से इलेक्ट्रॉन और प्रोटॉन मिलता है, क्योंकि यहाँ पे 1 2 3 कार्बन कंपाउंड है, यहाँ पे भी 3 कार्बन कंपाउंड है. सो ये डायरेक्टली क्या करता है, NADH प्लस H प्लस से इलेक्ट्रॉन विल रिसीव बाय होम दिस वन pyruvate. Direct particle, no protons is released, no proton is accepted by pyruvate, because here the proton is there, 3 4 2 protons are accepted, 3 2 as the 4 hydrogen molecules is there, and here the C6 hydrogen molecules is there. So here 2 hydrogen molecules as well as 2 electron molecules are taken. How many molecules? 2. In previous cases आगे भी ये 2 इलेक्ट्रॉन और 2 प्रोटॉन लिया था. कहाँ से? NADH. ये NADH कहाँ प्रोड्यूस होता है, मैंने बोला 3-फॉस्फोग्लिसराल्डिहाइड टू फॉस्फोग्लिसरिक एसिड. ये जो ग्लाइकोलाइसिस का स्टेप होता है, ये ग्लाइकोलाइसिस के स्टेप्स में जब 3-फॉस्फोग्लिसराल्डिहाइड टू 3-फॉस्फोग्लिसरिक एसिड प्रोड्यूस होता है, दैट इज ऑक्सीडेशन के टाइम, तो प्रोटॉन मॉलिक्यूल्स कहाँ जाता है, NADH, द रिड्यूसिंग पावर फॉर्म होता है. ये रिड्यूसिंग पावर अगर एरोबिक रेस्पिरेशन होता, इफ द सेल विल गो टू द एरोबिक रेस्पिरेशन, दे विल मूव टू द माइटोकॉन्ड्रिया. अगर एरोबिक रेस्पिरेशन होता तो ये माइटोकॉन्ड्रिया में घुस जाता. 2 रास्ते हैं वहाँ पे घुसने में. लेटर डिस्कस दैट इज ए मैलेट एस्पार्टेट शटल और ग्लिसरॉल फॉस्फेट शटल. ग्लिसरॉल फॉस्फेट से घुसता है और माइटोकॉन्ड्रिया में मैलेट एस्पार्टेट शटल से घुसता है. हाउएवर वो जरूरी नहीं है मेरे पास. ये क्या होता है, पायरुविक एसिड NADH से प्रोटॉन और इलेक्ट्रॉन को लिया और उसके बाद क्या हुआ, लैक्टिक एसिड फॉर्मेशन हुआ. So this is a very important steps. Another important thing is that Now this is the anaerobic respiration. Now lactic acid fermentation is very common in our muscle cell also. During the heavy exercise, what happened, our muscle cell get less amount of oxygen what is needed for the aerobic respiration instantly. So then what will happen, they just go to the glycolysis, and the glycolytic pyruvic acid will be converted into lactic acid and stored in a muscle, and this will cause a painful exercise. So this is the aerobic respiration overall. And another important thing is aerobic Pasteur effect. The term you will heard, that is the Pasteur effect. Pasteur effect क्या होता है? Pasteur effect during the glucose metabolism, if oxygen is present in environment, glucose की metabolism के दौरान अगर oxygen environment में है, तो they will never choose the anaerobic respiration, they will go to the aerobic respiration. So oxygen is a great inhibitor of aerobic respiration. So oxygen क्या होता है? Great inhibitor of aerobic respiration. It is an important thing. So this is called Pasteur effect. Pasteur effect आता है exam में. This is a very important. Now we will discuss about that is the respiratory quotient. Respiratory quotient. Light is gone. This is a common problem during pujas. During the puja के time, a common phenomenon is the load shedding. So this room is connected with an inverter, only one bulb, and so now we will go to the respiratory quotient, that is RQ. It is not written. RQ, respiratory quotient. Respiratory quotient is nothing but a ratio of what are the carbon dioxide produced during the breakdown of a glucose and what amount of oxygen is required. So ये कितना कार्बन डाइऑक्साइड प्रोड्यूस होता है और कितना कार्बन डाइऑक्साइड को लिया जाता है, इसको बोलते हैं रेस्पिरेटरी कोसेंट, RQ. So RQ is a value, RQ is a value of produced carbon dioxide, RQ is a value, that is how much amount carbon dioxide is produced by amount of oxygen is needed during the respiration. Respiration के टाइम एक मॉलिक्यूल ऑफ ग्लूकोज को तोड़ने के लिए कितना कार्बन डाइऑक्साइड जरूरी है, ऑक्सीजन जरूरी होता है, कितना कार्बन डाइऑक्साइड प्रोड्यूस होता है. दिस रेशियो इज RQ. So this RQ is different in case of different types of foods like your carbohydrate, protein and fat and some organic acids. They will produce they will show different RQ, and from this section you will see several questions, that is RQ is 1 in case of glucose. In case of proteins and fat, it is 0.7 to 0.8. In case of alcoholic fermentation, that I have already discussed. Alcoholic fermentation के time क्या होता है? Alcoholic fermentation के time, that is carbon dioxide is produced and oxygen is not needed. So it is infinity, that is carbon dioxide molecules, produce carbon dioxide molecule 0. So it is it is infinity. It is huge amount. And during the alcoholic fermentation, RQ in case of protein, in case of fat, and in case of RQ rate is in case of glucose, that is 6 CO2 and 6 oxygen is equal to 1. In case of glucose it is 1. So I will write here the different RQs at a stretch, so it will be better. क्या होगा? RQ को हम एक साथ लिखते हैं. क्या? RQ not written. RQ 1 in case of glucose, RQ less than 1, that is 0.7 to 0.8 in case of fats, in case of proteins, in case of it is RQ is infinity in case of alcoholic fermentation. RQ is 0. RQ is 0 in case of succulent plant, where the glucose is not partially converted into some organic acids. Like in case of succulents, we know that succulents will produce the malic acid. Succulents, it is 0. How? They require 3 molecules of oxygen, 3 molecules of oxygen, and no carbon dioxide is needed. No carbon dioxide is produced. So this is a 0. So in this way, in case of succulents, they need oxygen, but partial digestion of oxygen occur. So in this case, malic acid produced. We know that is in case of succulents. Succulent की time, succulents कौन होता है? वो जो मोटे पत्ते वाला plants होता है, that's a succulents. We know the C4 plants occur in case of succulents. Succulents और very important character को show करते हैं, जो है क्या? Stomata remains open during the night time. So this is a malic acid. So during the formation of malic acid, only 3 molecules of oxygen is needed from glucose. Glucose and malic acid not written. So during the formation of malic acid, only 3 molecules of oxygen is needed. So 3 molecules of oxygen, no carbon dioxide. So it is 0. So it is 0. Now, so the different part, that is a 1, less than 1, RQ, infinity, 0, and more than 1. RQ is more than 1 in case of organic acids. It is also organic acid. This is the malic acid formation. During the formation of malic acid, it is 0, but during the breakdown of organic acid, it is more than 1. That is during the in case of tripalmitin, it is a fat. That was a fat. It is less than 1. Okay. One question is there. Tripalmitin, it is an important fat. But in case of organic acid, succinic acid, malic acid, it's from the production of, due to the malic acid formation के time तो ये 0 है, but malic acid के breakdown के time ये more than 1 है. So if we'll see here, that is in case of malic acid के time क्या 3 oxygen and 4 carbon dioxide. Malic acid को breakdown करने में 4 carbon dioxide produce होता है और 3 oxygen required होता है. So 1 point something. So in case of malic acid, succinic acid, your oxalic acids, these are the different organic acid. So during organic acid is the more than 1. RQ rate is more than oxalic acid. Your oxalic acid, formic acid, succinic acid, okay, succinic acid. These are the different acids. During the breakdown of these acids, less oxygen is required and more carbon dioxide is produced. So why it is called that exercise is essential. That is, exercise will produce the lactic acid. So when they break down, they produce less amount of carbon dioxide, less amount of oxygen, high amount of carbon dioxide, less amount. However, this may be the different topic. So we'll discuss here. तो यहाँ पे हमने डिस्कस कर दिया कि रेस्पिरेटरी कोशेंट किसको बोलते हैं. So respiratory quotient, aerobic respiration, these are the different part. So this is the overall aerobic respiration. I will discuss the different MCQs, different important MCQs about aerobic respiration, anaerobic respiration, aerobic respiration, as well as the total respiratory pathway of plant respiration in later videos. You will keep watching and subscribe, as well as keep watching, because I will discuss each and every point of the topic Ncert, that from where the Neet question setters set the questions, how the question set. So here the high topic RQ is very important, and the steps of anaerobic respiration, that is the alcoholic fermentation. What are the different enzymes, what are the different metal ions present in enzymes? In alcohol dehydrogenase zinc ion is present. So in case of lactic acid fermentation, what happened? These are the different questions, and some logical questions may ask, that is, if we will exercise, why the muscles become painful, why they are painful. This is the lactic acid fermentation, and after getting rest, why it is gone. So this is due to the lactic separation of lactic acid fermentation. After rest require quite amount of oxygen is taken, and this oxygen helps in breakdown of lactic acid. So lactic acid removed. After the removal of the lactic acid हट जाने के बाद वो मसल्स पेन खत्म हो जाते हैं. लैक्टिक एसिड रहने से मसल पेन क्यों होता है, ये दिस डिफरेंट टॉपिक है, बिकॉज दिस इज लैक्टिक एसिड में इनहिबिट द मसल कंट्रैक्शन रिलैक्सेशन. सो these are overall your anaerobic respiration. If any questions, any point from anaerobic respiration that is you needed, you can ask me in comment section. So keep watching. Thank you.